I'm sharing my screen. Just wait. So in the last class, we completed with the data flow modeling and behavioral modeling. So today we'll discuss about the the behavioral modeling. Okay, what are these procedural blocks? Procedural blocks are nothing but initial and always blocks. Mostly first. Uh, so there are two delays are there that we'll discuss. Okay, don't worry. Just delays. Okay, delays. Mm, so first we'll discuss. Yeah, uh, delays. Okay, so delays are two types. Okay, so delays are two types. One is delays. So delays are two types. One is mm, inter assignment delay, and the next one is intra assignment delay. Okay, one is inter assignment delay, and next one is intra assignment delay. Intra assignment delay. So what is this intra assignment delay, inter assignment delay? So in detail we will discuss. But here inter assignment delay means delay. So that means inter assignment delay. So this inter assignment delay is nothing but whatever the delay we are mentioning, mentioned on LHS. Okay, on LHS, that is nothing but inter assignment delay. Suppose the example, if you take ash 5, a equal to what 1. Okay, this is inter assignment delay. Okay, and intra assignment delay means what? Whatever the delay is there, delay you are mentioning, you are mentioned on the RHS, that is nothing but intra assignment delay. Example, if you take uh, suppose a equal to hash 5, hash 5 and 1. Okay, this is intra assignment delay. Okay, so if you see like inter assignment delay with blocking. Okay, so there is inter assignment delay with blocking. Okay, so inter assignment delay with blocking, assignment. Okay, so inter assignment delay with blocking assignment, if you take uh, suppose if you take one example, module example, and I'm using reg a, initial begin. Okay, I'm using equal to 0 and hash 5 equal to what 1 and hash 10, hash 10 equal to 0. Okay, end and end module. Suppose if you are not representing any delay, so that means a becomes 0 at t equal to 0. So that means a becomes 0, t equal to at t equal to 0 time units. Okay, so so here what happens? So that means a becomes 1 after how many time units? A equal to 1 after, that means t equal to 5 time units. Okay, and a becomes 0 after this will be added, delay will be added. So T becomes 15 time units. Okay. Uh, mm, so what are the blocking assignments I told you yesterday? The assignments which are going to block further execution until present execution is complete. Okay. So until this present execution is complete, it is going to block this further execution. Okay. So that is nothing but we call as blocking assignment. Okay. So so blocking assignment. Suppose if you take one more example, so inter assignment delay with blocking. Suppose if you take uh, so suppose module example 2 initial begin. Okay. uh, so here a equal to 0 and hash 5 a equal to 1 and hash 10 a equal to 2. Okay. End module. Okay. So here what happens, so so first this will be executed at t equal to 0 time. So that means a becomes 0 at t equal to 0 time. Okay. So during execution of this instruction, okay, this will be in which state, means blocked state. Okay. After executing this instruction, next this instruction will be executed. Okay. So a becomes 1 at t equal to what, 5 time units. Okay. After executing this instruction, then this instruction will be executed. Okay. So a becomes 2 after 10 time units. Okay. After 10 time units. Okay. So this is nothing but blocking. Okay. Suppose yeah, so suppose if you see the non-blocking assignment. So non-blocking assignment means it will execute parallelly. Non-blocking assignment, it will execute parallelly. So suppose initial begin initial begin. A is non-blocking with 1 and A is non-blocking with 0 and A is non-blocking with 1. Okay. So so that means um, so here end. So in non-blocking, what happens? This is non-blocking symbol for non-blocking. So it is not going to block further instructions. Okay, it is not going to block further instructions. Okay, further instructions. Okay, so it will execute parallel. Okay, so this will execute parallel. Non-blocking assignments will execute parallelly. Okay. So what is the difference between blocking and non-blocking means? Mainly, so I'll write the difference between blocking and non-blocking assignments. Blocking assignments, blocking assignments, and non-blocking assignments. Non-blocking assignments. Okay. So what are these blocking assignments and non-blocking assignments? I'll tell you. Okay. So blocking assignments are nothing but these are mainly used for designing combination circuits. Okay. So these are used for combination circuits, and non-blocking assignments, these are used to design sequential circuits. Okay. This is used for sequential circuits. Sequential circuits. Okay. So if you take suppose one example, initial begin. Within an initial begin and block, I am writing a equal to 0. Okay. So so here a equal to 0 and end. Okay. I am initializing a with rich data type. So here what happens, whatever the 0 value is there, directly stored in a. Okay. Whatever this 0 value is there, so 0 is directly stored in a. Whatever the 0 value is there when you are using non-blocking assignment. Okay. whatever the zero value is there, that are directly stored in J. And non-blocking means suppose the initial, begin, suppose here you are using non-blocking with 0, okay, and end. So what happens, first this 0 will be stored in one temp register, okay, 0 will be stored in one temp register. From the temp register it will be stored in the A, okay. So that is like that, okay. So like this we can find out, that means directly it will not store in the A. First 0 will be stored in one temp register, from the temp register it will be stored in the A, okay. That is non-blocking, okay. So non-blocking. And suppose blocking with negage of clock, if you take now blocking with negage of clock, okay. So suppose if it is a passage of clock, suppose the always, if you are using always at the rate some passage of clock, always at the rate passage of clock, okay. Always at the rate passage of clock means what, here A equal to 0, A equal to 0 I am giving. So during this passage of clock, whatever the value of A, value of 0, that will be directly stored in A, value of 0 that will be directly stored in A, okay. Here suppose if it is non-blocking, always at the rate some passage of clock, always at the rate passage of clock. Suppose if I use non-blocking with a 0, okay, A with non-blocking with 0, first it will store in one temporary register, and from the temp register it will store in A, okay. So this is so mainly where you will get means this is used for designing D flip flops. So D, so if you are designing D, this is Q, and this is clock. Okay. So from this I can say that non-blocking is mainly used for designing combinational circuit, and whereas blocking is mainly used for the sequential circuit. Is it fine? Do you understood any doubts or queries? Shall I move forward? This is about the blocking and non-blocking with the uh, so with this this one. Okay. So next we will start with one second. Next we will start with, yeah. Next we will start with the delays. Okay, that I explained the inter-segment delay and intra-segment delays. No, so that I will explain. First, I'm talking about the inter-segment delays. Okay, inter-assignment delays. Okay, inter-assignment delays. So what are these inter-assignment delays? Suppose I told you like delays which we are representing on LHS, those are nothing but inter-assignment delays. Okay, delays delays on the RH, on the LHS, we are representing on the LHS. Okay, so example we already seen like ash 10 A equal to what 2. This is so that means here what happens, this is inter-assignment delay, inter-assignment delay. Okay, inter-assignment delay. So here after 10 time units, LHS equal to RHS. Okay. So here what happens in inter-assignment delay, after 10 time units. Okay, after 10 time units, 10 time units, LHS, that is equal to RHS. LHS equal to RHS. Okay, this is inter assignment delay. Suppose we'll take one example. So Regie initial begin hash to a equal to 1 and end. Okay, just after after t equal to 2, what is the value of a before t equal to 2, what is the value of e? Can anyone say? Are you there? Hello?
Uh, After t equal to 2 equal to 1.
One second. One second. Yeah, tell me. After t equal to 1. Okay, after t equal to equal to 1. Okay, after t equal to 1 and before t, yeah, before t equal to x. Why? Because, yeah, so what is the default value for edge data type? X. Okay, so the default value for edge data type is x. Okay, so this is one example, and we'll see one case one. So case one, inter assignment delay with blocking operator. Inter assignment delay with blocking assignment with blocking assignment. So suppose initial begin hash 5 equal to 1 and hash 10 equal to 0. Okay, end. After how many time units a becomes 0? After t equal to how many time units a becomes 0? So, 15 t equal to 15 time units a becomes 0. So that means, so this is a blocking assignment. So when this is in means this a becomes 1 with 5 time units. Okay, this time will be added. So 5 plus 10 means a becomes 0 after how many time units? T equal to 15 time units. Okay, this is case 1, and next we will see case 2, inter assignment delay with non-blocking. Inter assignment delay with non-blocking. So inter assignment delay with non-blocking. Let us take one example. Initial begin. Uh, so delay is represented before the variable, no, on the LHS side. So A is before the variable. The A is non-blocking with 10. Okay, and this is NBA non-blocking assignment. NBA and hash 15. A is non-blocking with 1. Okay, and end. So a equal to 0 at what time minutes and a becomes 1 at what time minutes? Any idea? A equal to, yeah, A equal to, yeah, here A equal to, here A equal to 10 at t equal to what, 10 time minutes, and A equal to 1, A equal to 1 at t equal to, uh, so 10 plus 15, 25, 25 time minutes, 25. So this will be added for non-blocking also, inter-assignment delay also, this delay will be added. Okay, so this will be executed. A becomes 10 at t equal to 10 time minutes, and A becomes 1 at t equal to 15 time minutes. Okay, so next, intra assignment delay. So intra assignment delay means, uh, intra assignment delay, we are representing the delay on the RHS. So we are representing the delay, delay is mentioned on the RHS, mentioned on RHS. Okay, example, A equal to hash 5 1, A equal to hash 5 1. Okay, so this is intra assignment delay. Okay, so this is intra assignment delay. So what is the difference between inter assignment delay and intra assignment with delay with blocking? Okay, so I'll write the differences. Inter assignment delay, inter assignment delay, and next, intra assignment delay, intra assignment delay. So here inter assignment delay means, here if you see, suppose A, hash 5 A equal to some 1. Okay, so this whole statement will be executed after 5 time minutes. Okay, this whole statement, okay, whole statement, I'll write here, whole statement will be executed, will be executed after, after 5 time minutes, 5 time minutes. Okay, so here, so that means here, same thing, suppose hash 5, hash 5 some A equal to, equal to 1. Okay, so this whole statement will be executed after time, so whole statement will be executed after 5 times. Okay, and here here what happens, A equal to hash 5 and I am giving 1. Okay, so after 5 time minutes value will be equal to LHS. Okay, RHS value will be equal to LHS after, in intra assignment delay, after 5 time minutes, 5 time minutes, RHS value, RHS value will be equal to, will be equal to LHS, will be equal to LHS. Okay, so that means here in inter assignment delay, whole statement will be executed after 5 time minutes. Okay, in intra assignment delay, after 5 time minutes, the whatever the RHS value is there, that will be equal to the LHS value. Okay, so this is the difference between the, mm, inter assignment delay and intra assignment delay. Okay, so if you see, intra assignment delay with blocking, one second, I will add the slide. So if you see the inter assignment delay with blocking, okay, intra assignment delay with blocking, so case 1 will check. So case 1, intra assignment delay, assignment delay with blocking, with blocking. Okay, so here, what happens, initial, so initial, begin, some A equal to, this is blocking assignment, hash 5 1, and B equal to, B equal to, hash 10, hash 10 1. Okay. After how many time minutes the A becomes 1, and after how many time minutes B becomes 1. Can anyone say? After 5 time minutes A equal to 1. After, no, here blocking, no. So blocking intra assignment delay means 15, 15. Okay. So 15. So from this, what you can conclude, that means in case of blocking assignment, so conclusion, conclusion, in case of blocking assignments, blocking assignments, intersegment delay, intersegment delay, and intrasegment delay, and intrasegment delay, intrasegment delay work as same, work as same. Why? Because if you see the operation of intersegment delay, intrasegment delay in the blocking, both the time units, means the times are adding. Okay, here at t equal to 5 time units, the value will be updated. A becomes 1, and after t equal to 5 plus, so that means this is 5 plus 10. So 5 plus 10, that is equal to 15 time units. B becomes 1. Is it fine? So this you need to understand. So whatever I am telling, these are some interview questions. That means you need to be clear. So they will try to confuse you about the intersegment delay and intrasegment delay. So if you remember this concept, within the blocking assignments, both intersegment and intrasegment delay will work as same, means you can answer confidently. Is it fine? Shall I move forward? Any doubts or queries? Okay, thank you. So next, next case two. Intra-segment delay, intra-segment delay with non-blocking, intra-segment delay with non-blocking. So intra-segment delay with non-blocking, let us take initial, begin. I am giving A non-blocking with 5. Okay, non-blocking with here I need to use A with non-blocking with hash 5 0, B with non-blocking hash 10 1. Okay, end. So here after how many time units the B value becomes 1? Yeah. So after, yeah. So that means here what happens? Two instructions. This is a non-blocking assignment. Two are running in parallel. Two are running in parallel. Okay. Two are running in parallelly. So what happens? Compiler don't want to wait for waste the time. Waste the time. So what happens after 10 time minutes? After 10 time minutes, what happens? B will be initialized to 1. Okay, so like this. So we'll take with one example, one more example. Suppose example 2, initial, begin. A is non-blocking with 10 1, and B with non-blocking with 5. Okay, these examples you can see in the tool or EDA playground, that you need to display, or display the value of A is percentage d comma d, like that you can see, we can see the output and you can try to understand. So here what happens when the value becomes 1? When the b value becomes 1? Yeah. So two are running parallelly. So two are running parallelly. So b becomes 1. Okay. So whatever the compiler, so compiler will execute execute which is having the least time. Okay, which is having least time. What about others? Only one is responding least time. Okay. So this is so that means conclusion I can write conclusion. So what is the conclusion I can write? Inter assignment delay acting as blocking operators. Inter assignment delay assignments is acting as blocking. Okay, is acting as uh, blocking operators, as a blocking assignments. Blocking assignments. Okay. Next case 3 I will check. Case 3, initial begin. Suppose hash 5 A is non-blocking with hash 10 1. Hash 5 B with B non-blocking with hash 8 0. Okay, end. After t equal to how many time minutes, the A becomes 1. Okay, after t equal to how many time minutes, the B becomes 0. Tell me. Anyone? Mm-hmm. Mm. Yeah. T equal to 18. First, t equal to 15 means here, so here this will be added and this will be added. So 5, so 5 plus 10 means how much? 15. So after 15 time minutes, A becomes 1. And here it will take the, so that means it will not include, this will not include. Okay. So next this delay will be included. So 5 plus 10 plus 8. So after t equal to 18 time minutes, B becomes 0. Okay. So this is about the blocking and non-blocking assignments. Any doubts or queries in this? So that I will move forward. Shall I move forward? Okay. What about others? Okay. So next we'll start with this Verilog Event Scheduler. Verilog Event Scheduler. So Verilog Event Scheduler. So here, suppose if you take hmm, so this in Verilog Event Schedulers, you have like uh, one is active region. Okay, so you have active region, and next you have inactive region, active region, inactive region, and NBA region. NBA region. NBA is a non-blocking assignment. Non-blocking assignments, and you have postponed region. Postponed region. Okay, postponed region. So first we will discuss about the active region. Okay. So what is this active region? Active region means what instructions will be executed in the active region means active region. Uh, so blocking assignments in active region, blocking assignments, and dollar display statements, and it will evaluate the RHS of NBA. Okay, so evaluation of RHS, whatever the RHS to NBA region, and continuous assignment statements, continuous assignment statements, and it will evaluate the inputs. It will evaluate the inputs, and update the primitives. Update the primitives means like update the primitives means gate level primitives are there, no? So update the primitives in the gate level modeling. We already seen like and or okay, not okay. These all are gate level primitives. Okay, this will update the primitives. Okay, so just we'll see one program. Okay, so suppose I'll show in the EDA playground only. Uh, so you need to open. So these blocking assignment, dollar display statements, evaluation of NBA will be not executed. This will evaluate the RHS of NBA and continuous assignment statements and evaluate the inputs and update the primitives. Okay. So just I'm opening the EDA playground. So I'll write one code and I will show you how it will execute. So you need to uh, register with your mail ID in the EDA playground. So here you need to write the test bench and here you need to write the design. So I'm not writing the test bench, just I need to write the design only. Okay. Suppose if you take so module test. Okay. Module test. I'm initializing reg a comma b, initial begin, and I'm using a equal to 0 and b equal to 1, I want to display. Okay, dollar display the value of a is percentage d, and b is percentage d, and a comma b. Okay, a comma b, and I'm introducing one delay.